All right, and we're back. Hey, chemistry class. Nothing new today, just going back and reinforcing the idea of double replacement reactions and single replacement reactions and that kind of stuff. You'll want to have both your activity series ready and, on the other side, your solubility rules ready because you'll need those as we go on and do some of these examples together. So we're working on this worksheet. Worksheets on single and double replacement reactions. And it's just a combined worksheet. Notice it gives you them in word form, so this is a little more practice writing the formulas from the words. You can never do that too often, because if you don't write the formulas correctly, you'll never get them to balance. It just doesn't work. It's not a happy time. So let's do some of these together just to see what we got. So number one, this first section, all single replacement reactions. Let's do a couple of those. Zinc plus hydrogen chloride, which I would usually call hydrochloric acid, but hydrogen chloride is fine. And that, of course, will react. So we look at our single replacement sheets. And I see that, yes, there's zinc, and that will replace hydrogen. So we're good to go. So that will form zinc chloride and hydrogen. Hydrogen, of course, is diatomic. And this is relatively easy to balance, right? If I want to do the whole thing, zinc, hydrogen, chlorine, 1, 1, 1, 1, 2, 2. So put a 2 right there, and we're all balanced. So there we go. Okay, let's do another one. Let's pick, I don't know. Let's go, I like number 5. We'll do number 5. Potassium iodide and bromine. Of course, bromine part of the Hofbrinkel, so it's Br2. We go to my activity series sheets. Looking down here for the halogens, will bromine replace iodine? Yes, it is above, so it will replace. So I end up with KBr plus I2, and I is again part of the Hofbrinkels. If I wanted to balance this, need a 2 here to balance the iodines. Need a 2 here. And we're good. So that's pretty simple. Again, if there's no reaction, right? No reaction. Or in this case, they abbreviate. I guess I never mentioned that. Reaction is abbreviated RXN. So you don't have to write out the whole word of reaction. You can just put RXN. It's easier. Let's do a couple of the double replacement ones. So down here under double replacements, we have barium chloride. We'll do double replacement number 1. Barium chloride, BaCl2, and aluminum sulfate, Al2SO43. Remember, crossing your charges. And again, double replacement reactions. So like replaces like. The positive switch. We'll get aluminum chloride and barium sulfate. And remember, one of those has to be not aqueous for this to work. So we look here and we see that halides, so like aluminum chloride, are all soluble except silver, lead, and mercury. So aluminum chloride will be soluble. Sulfates are soluble except silver, calcium, strontium, barium. So this would be insoluble, so that would form a solid precipitate, while this would be aqueous. So this will occur, we're good to go. And then, of course, go back and balance it. Barium, chlorine, aluminum, sulfate. 1, 2, 2, 3. 1, 3. 1, 1. All right, metals first, but the bariums are okay. So let's go on to the sulfates, 3 and 1. This needs to be multiplied by 3. Changes my bariums and my sulfates. I'll have to go back and fix the barium, but we'll do that at the end. Aluminum, 2 and 1. So this needs to be a 2 over here, making that a 6, and that a 2. And now this needs to be a 3 over here, making that a 3 and that a 6. And we're good to go. Everything's balanced. So there we go. Let's do another one of those. Let's go ahead and grab... Oh, let's do number 5 again. We'll do 1 and 5 for both of these. It'll be great. Calcium hydroxide. Reacting with ammonium chloride. And that will form calcium chloride and ammonium hydroxide. Uh-oh. Ammonium hydroxide. That's one of those unstable ones, right? We'll get to it. Let's double check and make sure. Actually, no. Take that back. Ammonium hydroxide is unstable, so that'll make ammonia and water. Okay, so that automatically breaks down. Again, let's double check to make sure this is okay. Calcium chloride, again, all the halides are soluble with a couple exceptions. Calcium is one of them, so this would be aqueous. NH3 then is one of our common gases. That's ammonia gas. So this would be gaseous, and water, of course, is a liquid. So this will proceed because we have a gas that forms. We're fine. Balancing this, let's see here. I have calcium, and this is where it gets a little tricky. I've told a couple of you about this who asked. It's almost easier to balance it as ammonium hydroxide and then solve that at the end. So let's do it that way. I have 1 calcium, 2 hydroxides, 1 ammonium, and 1 chlorine here. 1 calcium, 2 chlorides, 1 ammonium, and 1 hydroxide there. So as I'm balancing this, I have to put a 2 over here. That doubles my chlorines and my ammoniums. So I need to put a 2 over here, and that would be balanced. So since I had a 2 here, and that split apart, these both become 2s. And now it's balanced that way. It's almost easier to balance as the ammonium hydroxide and then transfer it over to the new creation after it splits apart. All right, the bottom section then is all about mixed reactions. Some of them are single replacement, some of the double replacement. It should, I hope, be really easy to tell the difference, because if there's a single element, it's single replacement. If there are 2 compounds, it's double replacement. So hopefully that shouldn't be too bad for you. Let's do let's do 1 and 5 again. So number 1, zinc and silver nitrate. Okay, that's a single replacement reaction because zinc is by itself. So will zinc replace silver? There's zinc, there's silver. You betcha, zinc will replace silver. So I'll make zinc nitrate. And silver. Silver is not diatomic. It's not a Hofbrinkel. So balancing this. There we go. Balanced. Yes, I can balance them in my head. I've done this a lot. It gets easier with time. Let's go ahead and do number 5. Potassium fluoride and lead 2 nitrate. Well, potassium. Fluoride, lead, nitrate. Okay. Double replacement reaction, 2 compounds. So lead will bond with fluorine, and lead keeps its positive 2 charge across the reaction. And then potassium nitrate. Okay, let's take a look and see if this will occur. Again, we need a non-aqueous substance. Lead fluoride. Okay, fluoride is a halide. So look at my halides here. Halides are all soluble except the lead 2 ion. Okay, so this would be a solid. So that means this will occur. Potassium nitrate would be aqueous. but it hardly matters at this point. All right, so balancing. Need a 2 here, need a 2 here, and we're balanced. All right. Hope this is getting easier for you. Hope you're understanding what's going on. Just remember, keep track of your friends, of the activity series and the solubility rules. Make sure your periodic table is handy. If you still haven't learned those polyatomic ions like you were supposed to, it's not too late. You can still learn those because it really does help out to be able to recognize those as well. If you have any questions, as always, get a hold of me. Have a great day.